Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method. So let's get going. Problem: solve y double dash plus 4y equal to 4 secant square 2x, or d square y by dx square plus 4y equal to 4 secant square 2x, or d square plus 4 into y equal to 4 secant square 2x using variation of parameters method. So we are given a differential equation of order 2, right? Given differential equation, y double dash plus 4y equal to 4 secant square 2x, considered as equation number 1. We can write y double dash as d square y by dx square plus 4y equal to 4 secant square 2x. Now write d square y by dx square as capital D square y using the differential operator d, plus 4y equal to 4 secant square 2x. Now take y common from the two terms of LHS, we'll get d square plus 4 into y equal to 4 secant square 2x, considered as equation number 2, which is in operator form. So equation 1 and equation 2 in operator form is our equation 2. So f of d into y equal to 4 secant square 2x. Okay, f of d into y equal to r of x, where f of d is d square plus 4 and function of x or of r of x is 4 secant square 2x. f of d is d square plus 4 and r of x is 4 secant square 2x. Let's now write the homogeneous equation of equation 2. The homogeneous equation of 2 is d square plus 4 into y equal to 0, considered as equation number 3. Now we'll find the solution to the homogeneous equation using the auxiliary equation, and later using the auxiliary, the solution of homogeneous equation, we'll find the general solution of the given equations. Okay. Now coming to the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square plus 4, right? Let's replace the differential operator by m so that we'll get f of m equal to m square plus 4, and the auxiliary equation becomes m square plus 4 equals to 0. Now we need to find roots to this equation, so we'll take plus 4 to RHS, we'll get m square equals to minus 4. From this we'll get m equal to plus or minus square root of minus 4. Let's now write square root of minus 4 as square root of minus 1 into 4, and now split the square root as square root of minus 1 into square root of 4, since we know that square root of minus 1 is I and square root of 4 is 2. So the above equation becomes plus or minus I into 2. Therefore m equal to plus or minus I to or 2i. The roots are complex conjugate. We know that when two roots say m equal to a plus or minus ib, it's a pair of complex conjugate roots, then the solution to homogeneous equation looks like y equal to e power ax into one constant, say c3 cos bx, plus another constant, say c4 sin bx. In case of a0, we'll get e power 0 into x, which is e power 0 into c3 cos bx plus c4 sin bx. Since e power 0 equal to 1, this gives us 1 into c3 cos bx plus c4 sin bx, right? From this we'll get y equal to c3 cos bx plus c4 sin bx. Here we are taking C3, C4 instead of C1 and C2 because we want C1 and C2 to appear in the last general solution. Now, coming to the solution of homogeneous equation. The solution to homogeneous equation, equation 3, is y equal to C3 cos, just compare plus or minus I2 with plus or minus IB, then for B equal to 2, you'll have y equal to C3 cos 2x plus C4 sin 2x. Okay, therefore y equal to C3 cos 2x plus C4 sin 2x is the solution to our homogeneous equation. Let y equal to, now just replace the constants or parameters with some functions of x, a and b. We'll have a cos 2x plus b sin 2x, be the general solution to the given problem. Or given equations, whatever, where a and b are functions of x. Now you can compare the the solution to homogeneous equation with y equal to C3u plus C4v, or the general solution to our problem with y equal to au plus bv. Okay, so that you'll get u and v, where u is cos 2x, v is sin 2x. See, u is cos 2x and v is sin 2x. And here we'll find a and b using formula. A is given by, or we'll get a from a dash, b from b dash, where a dash and b dash are. A dash is given by minus v into r of x by uv1 minus vu1, and b dash is given by u into r of x by uv1 minus v1. If you notice, we are having uv1 minus v1 in both the formulas, so we'll begin with uv1 minus v1 and later we'll find a dash a, b dash b, and finally we'll substitute a, b in y equal to a cos 2x plus b sin 2x to find the general solution to our problem. Now coming to uv1 minus v1. v1 is nothing but v dash, u1 is nothing but u dash. U dash and v dash are derivatives of u and b. Is equals to u is cos 2x into v dash sin 2x dash minus v into u dash cos 2x dash. This gives us cos 2x into derivative of sin 2x with respect to x is 2 cos 2x minus sin 2x into derivative of cos 2x with respect to x is minus 2 sin 2x, right? This gives us 2 cos square into cos square is cos square 2x, minus into minus plus 2 sin 2x into sin 2x is sin square 2x. Or we can just write this as 2 sin square 2x plus 2 cos square 2x. Now take 2 common from these two terms, we'll get 2 times sin square 2x plus cos square 2x. Since sin square theta plus cos square theta equal to 1, so we can replace sin square 2x plus cos square 2x by 1, so that you'll get 2. Therefore, uv1 minus v1 equal to 2. We'll find a dash now. A dash is given by minus v into r of x by uv1 minus v1, right? This is equals to minus v sin 2x into r of x 4 secant square 2x by uv1 minus v1, which is 2. This gives us minus 2 secant square 2x sin 2x, right? Now we can split, or we can write secant square 2x as secant 2x into secant 2x. Since we know that secant theta is reciprocal of cos theta, so just replace 1 secant 2x with reciprocal of cos 2x. We'll get minus 2 into secant 2x into reciprocal of cos 2x into sin 2x. Right? We'll just replace the secant 2x with reciprocal of cos 2x here. Is equals to minus 2 secant 2x into 1 by cos 2x into sin 2x is sin 2x by cos 2x. Since we know that sin theta by cos theta equal to tan theta, so just replace sin 2x by cos 2x with tan 2x. You'll get minus 2 secant 2x into tan 2x, right? Therefore, a dash equal to minus 2 secant 2x into tan 2x. Let's now find a using this a dash. We have a dash equals to minus 2 secant 2x tan 2x. A dash is nothing but derivative of a with respect to x equal to minus 2 secant 2x tan 2x. Let's now separate the variables by taking differential dx to RHS. We'll get dA equal to minus 2 secant 2x tan 2x dx. Here the variables are separable. So let's perform integration. Right? Since we know that integral secant ax tan ax dx equal to 1 by a secant ax, so the above equation becomes integral dA a equal to minus 2 into integral secant 2x into tan 2x dx is for just compare the integrand with secant ax tan ax, and for a equal to 2 you'll have 1 by 2 secant 2x plus integral constant say sum c1. A gets cancelled, 2 gets cancelled, and you'll get a equal to minus secant 2x plus c1. Therefore, a equal to minus secant 2x plus c1. We got a now. Let's now find b dash and b. B dash is given by u into r of x by uv1 minus v1. U is cos 2x into r of x 4 secant square 2x by uv1 minus v1 is 2 is equals to 2 cos 2x secant square 2x. Now write secant square 2x as secant 2x into secant 2x for our convenience. And we know that secant theta is reciprocal of cos theta. So just replace secant theta replace 1 secant theta or secant 2x with reciprocal of cos 2x. We'll get 2 cos 2x into 1 by cos 2x into secant theta. Cos 2x gets cancelled, we'll get 2 secant 2x. Therefore, b dash equals to 2 secant 2x. We have b dash equals to 2 secant 2x, right? B dash is nothing but derivative of b with respect to x equal to 2 secant 2x. Let's now separate the variables by taking differential dx to RHS. We'll get db equal to 2 secant 2x dx, where the variables are separable. We can perform integration now. since integral secant ax dx equals to 1 by a log mod secant ax plus tan ax, so the above equation becomes integral dv be equal to 2 into, just compare secant to x with the integrand secant ax, then for a equal to 2 you'll have 1 by 2 log mod secant to x plus tan to x plus some integral constant, say c2. 2 gets cancelled and we'll get b equal to log mod secant to x plus tan to x plus c2, or b equal to log of secant to x plus tan to x plus c2. We got a and b. Let's now find the general solution using y equal to a cos 2x plus b sin 2x. Therefore, the general solution is given by y equal to a cos 2x plus b sin 2x. Substitute a and b. We have a minus secant 2x plus c1 into cos 2x plus b log of secant 2x plus tan 2x plus c2 into sin 2x. This gives us minus secant 2x cos 2x plus c1 cos 2x plus sin 2x log of secant 2x plus tan 2x plus c2 sin 2x. Here we are having secant 2x into cos 2x, right? Let's replace cos secant 2x with reciprocal of cos 2x, since secant theta is reciprocal of cos theta. Or you can replace cos 2x with reciprocal of secant 2x, whatever. Now I'm going to replace secant 2x with reciprocal of cos 2x into cos 2x plus c1 cos 2x plus sin 2x into log of secant 2x plus tan 2x plus c2 sin 2x, right? Cos 2x gets cancelled, you get minus 1 plus c1 cos 2x plus sin 2x log of secant 2x plus tan 2x plus c2 sin 2x. Or we can write this as y equal to, write the terms involving c1 and c2. Firstly, we'll have c1 cos 2x plus c2 sin 2x minus 1, write the remaining terms minus 1 plus sin 2x log of secant 2x plus tan 2x, right? Therefore, y equal to c1 cos 2x plus c2 sin 2x minus 1 plus sin 2x into log of secant 2x plus tan 2x is the required general solution to our problem. So we have seen a problem from variation of parameters method in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.